Welcome to the last chapter of the class. We're going to take a look at two more hypothesis tests, the two-sample t-test, where you're comparing two group means against each other, and then the paired t-test. So each person in your sample has two measurements, like a before and after, and we're going to compare the difference of those measurements. So recall this example from chapter 20. Does the expectation of good weather lead to more generous behavior? Psychologists studied the size of the tip in a restaurant when a message indicating that the next day's weather would be good was written on the bill. So if you remember that data set, there were actually three columns of data. There was the tip percentage for good weather messages, there was a tip percentage for bad weather messages, and then there was a tip percentage for no message written on the receipt at all. So a question you might be interested in if you were a waiter or waitress or in a tipped position is, at the 5% significance level, is there evidence that the good weather message results in a better tip than the no weather message does? So this is a great question. And to do that, we need to do something like a two-sample t-test. So a two-sample t-test is where you have two independent groups. So we have the group that got the good weather message, and we have a totally separate group that got the no message on their bill. So our hypotheses here, there's still the same idea applies. The null hypothesis is still a claim by an authority figure, but now we're going to compare the mean from each group. So we have a mu1 and a mu2, or in terms of that good weather, bad weather, we'd have a mu with a good weather minus a mu with a no message. And in this class, we're always going to set these equal to 0, which means there's no difference really between the means. If you take a more sophisticated stats class, you certainly can adjust that to be a different number. But we're going to stick with the tried and true, just simple to introduce this idea that these two means are really the same. Okay, and then our alternative hypothesis. So this is still the claim that's challenging the authority figure, and it will be written as mu1 minus mu2. And then you'll either use a less than, greater than, or not equal to symbol. So there is a tip here, and when we get to the next video, I'll actually practice this tip with you so you can see what it means. But it says start by comparing those two means. So if I thought the good weather message was going to get me better tips than the no message, I would change my caret this way so it's facing those good weather messages. And then I can shift the no message one over. So I know that sounds like a lot. I promise I'll do it with you in the next video so it'll make some more sense. But there is a trick to doing that that'll help you, I think. So as always, there are four parts to a hypothesis. You need to tell me which one you have, the null or the alternative. You need to have the mean mu somewhere in there. So in this case, for this type of test, it's going to be mu1 minus mu2. You need some sort of sign, and equals, less than, greater than, not equal to. And then you need a value. And we're going to use 0 for the two-sample t-test for all of these. So that makes that a little bit easier. All right, so come back in the next video. I will show you how that tip works, and then you can try out some more hypotheses.